later we will learn more about the C preprocessor and about statements. And you may think there is not much to say about statements, but actually in 2011 for C11 there was a clarification about how for loops work, but more about that later. And then some aspects about writing portable C. So the preprocessor, it consists of these things, and we will look at one at a time. So predefined macros. They are macros that we can use directly in the source code, and the compiler will fill in what they mean. For instance, if we write this, then the compiler will replace this macro name with a string that contains the name of the source code file. The next will be replaced with a line number where this where this identifier was written. Date is it's the day and year and month when it was compiled. And time, well, that's self-explanatory. Standard C, that's not very useful. When C was standardized in 1989, there was some enthusiasm that there was a standard, and if this macro was, well, there was a lot of enthusiasm, but when this macro was introduced and it expands to 1, it means that the compiler, meaning the implementation, which is the compiler and the library, conform to the C standard. The only problem was that they didn't mention which C standard. So that one is usually not used. Instead, there is another one called standard C version, which, for instance, can expand to this if it conforms to C99. Standard C hosted, that is used either for a freestanding environment or a hosted environment. Freestanding means that it is for an embedded system where certain library functions for manipulating files, for instance, they don't have to be available. Okay, so then we can check if, we can use conditional compilation to see if we are allowed to use such library calls or not. Okay, these are implementation defined, whether they are defined and expand to 1. And if this one does, then it means that the floating point environment follows the IEEE standard. And basically that means it's the same as most other languages use, including Java. Well, Java is not exactly following this standard, but Fortran and Python and many other languages. This is extremely common that the hardware does this. Okay, it's optional to support complex numbers, and if this if the compiler supports it, then this it can be checked with that. And this is to indicate that certain so-called wide character types are supported. Okay, we are not allowed to undefine a predefined macro. To undefine a macro, we use hashtag undef and the macro name, but we are not allowed to do that with any of the predefined ones. Okay, so what is now a macro? Well, the ones we have seen here, they are available, as mentioned, from the compiler, so we can just write these identifiers. But if we want to create our own macros, we can do that. And we do it with the define keyword, hashtag, or I just say hash, and define, and then identifier. And now one must be very careful, because if there is space or something other than a left parenthesis, then this is called an object-like macro. And if there is a left parenthesis, then it is assumed that this is the beginning of a parameter list, which must, well, clearly have a right parenthesis as well. So even though this looks like some kind of function, it's not. Okay, so let's see what happens when we use this. If we have obj, then this obj is replaced with what was to the right of this identifier. Okay, so the compiler will, or actually the preprocessor, will just copy this and paste it here, almost exactly. Multiple space or tab characters, they are replaced with a single space character. Okay, so obj becomes this, and then follows the parenthesis and 3 there. Okay, so even though this looks like a function call or something like that, it's not, because obj is a so-called object-like macro. And this object has nothing to do with object-oriented programming. It's just the opposite of a function-like macro. And the function-like macro takes parameters. Okay, so how should we write a macro which takes parameters? This is a bad solution because, well, if we use bad here and 3 and multiply this with 10, then we might expect it should be 3, 4 and 40. But since we have no parentheses around this, it will be 13 instead. So what we should do is to put at least everything on the right hand side here in parentheses. Sometimes it can result in a syntax error, and sometimes it's not necessary. For instance, if we use a flag to say that the debug printing should be used, or a certain version of something should be used, we can just use a macro to be either 0 or 1, for instance. Then there is no problem. But usually it's always best to have everything here in parentheses. Okay, so this is an example of a good macro. What happens then is that the preprocessor sees this name. Well, it was already in the bed. It sees this identifier and checks, is this a macro? Okay, it realizes it's this macro, so it starts looking for all of the parameters, and there is only one, so then it has found it, and then it replaces the definition of this macro with the text. I mean, it puts the definition in the source code. It does not change the source code, but internally during compilation. And the same thing happens here. If we, for some reason, do not want to expand this as a macro, then we can prevent this expansion by not having a left parenthesis as the next character, because the preprocessor sees this identifier, and since it's a function-like identifier, it checks if the next non-space character, that is blank, tab or new line, if the next non-space is a left parenthesis, then it will start looking for parameters. If it's not the left parenthesis, it just ignores this and just lets it remain in the code. So one way to avoid syntax error and still not having a left parenthesis is to put this identifier in parentheses. So it will check really if this is left parenthesis, and since it's not, it will just ignore it. And it will leave this as it is. Conditional inclusion. If we define a macro name, we can check if it has been defined or not. If it's not defined to anything in particular, it's given the value 0. So if we want to check this, we can use if-def debug, and since debug was defined, this source code will be included during the compilation. And we can also check the opposite using if not def. Alternatively, we can use an expression here. If we use if debug, then this debug will be treated as a 0. So it's better to use debug and write a 1 to here. So there should be a 1 if we want to use this check. Yeah. And there is elif and else if, I mean, with this syntax, and else and end if.